Hey everyone, welcome to Studio Review. It's Kyle, and in this video, we're going to be going over spinning the discs. The goals of the studio are to discover the differences between CDs and DVDs, growing our knowledge on inheritance as well as into interfaces, then finally using all that knowledge to have abstract classes and interfaces work together to build an application. The first thing we need to do in the studio is fork the repository called Java Web Dev Studio 7. Specific examples were given to us to do this. What we need to do is go to the instructions and click on Visit the Repository page. Then, just like normal, we go up to the fork and we click it to fork it into our account. Once it's forked, we open IntelliJ and we go to Get from Version Control. We go to our account, then we select the new project we just forked, and then we press Clone. It will clone it for us to our computer. Then finally, it will open it for us. We come in here and we see that our source folder is here with everything that we need to use in order to complete the studio. Perfect, let's move on. Next, one thing to call out that this is a group studio, so we're going to be working with a fellow student as we move through this. With that fellow student, we need to decide on two more behaviors to add to our list of behaviors that we see in the studio for CDs and DVDs. For this, feel free to use a search engine. Looking at those behaviors that they give us 5 initial ones, but then we have to come up with 2 more. The ones I'm going to be using as an example are both are inserted into a computer and both have a limited storage capacity. These are 2 more behaviors of CDs and DVDs that I can use. This is just my approach. However, remember, you can use whatever behaviors that you see fit. So now we have to take that list of behaviors and we have to sort them and decide if it's going to fit in an abstract class or inside of an interface. But before we do this, let's go ahead and remember the differences between abstract class and interfaces. Abstract classes are able to have class variables inside of them, as well as private methods, and can also consist of complex functionality or long methods to pass down to their children. Interface is a little bit different. It can only have public methods to supply to its children. Inside of it too, we also see only simplistic functionality, if any, by using that keyword default. And then finally, we're only going to include methods in here if we know they will not have any shared functionality between the children. So we have to keep all this in mind as we're doing our sorting. So let's get to that. The first behavior we had was they both spin. Well, we know that CDs and DVDs both spin, but they spin at different rates. Therefore, they spin differently. This functionality won't really carry over between the two. Because that functionality won't carry over between the two, I know it's going to fit into the interface. The next one is they both store data. Now, both of them again store data, but they store it at different storage capacities. But I know that both the DVDs and CDs have to store data, but they'll just store it in different ways. Therefore, I'm going to supply this one to the interface as well. The next one up is data gets written to the disk using a laser. Well, I know this one's functionality is going to be fairly similar. Both are going to write to the disk in the same way using that laser. So I can share that functionality between my 2 children using the abstract class. Therefore, I'm going to put it under the abstract class. Next is the data on the disks can be read by using the laser. Well, just like the previous one, reading the data too shouldn't differ too much in functionality. We should just read the data and return it to our user. So I'm going to put that one under the abstract class as well. I also know that these 2 will probably be using the class variables to store and read the data from my disk. Another clear indicator that it will be in the abstract class. Next, they both report information like name, capacity, etc. Well, in order for it to report information like this, it has to store information like this. I know that class variables have to store information like the name and capacity. Therefore, I'm going to put this in the abstract class because I know it's going to be interacting with those class variables. Both can be inserted into a computer. Well, inserting is not going to really differ between CDs and DVDs, so that functionality can be shared between children. So I'm going to add that to the abstract class. They both have limited storage capacity. Well, CDs and DVDs share this characteristic, but that storage capacity could be different. Therefore, I'm going to want to implement this behavior a little differently between CD and DVD. So I'm going to put this into interface. Now, I sort up these behaviors how I saw fit. We can always make arguments of why something should be in an abstract class or back into interface. So definitely take this with a grain of salt and implement it the way you see fit. Try it out in code and see if it works. So taking these behaviors, we're going to now turn them into methods. Looking at interface first, we took what those behaviors were and made method names out of them. We're going to do the same for the abstract class as well. Part of our instructions also say we need to provide some properties into this. So one they give us in our instructions is storage capacity. I'm going to call it storage capacity in MB, megabytes. I know the storage capacity for DVDs and CDs are going to be different. So this property, I feel, will go into the abstract class. I feel it's going to go into the abstract class because one, interfaces typically don't hold class variables. And two, I know if it goes inside the abstract class, I can force my children to define their own storage capacity. The next one is spin speed in RPM, rotations per minute. I know my DVDs and CDs spin at different rates. So again, because they spin at different rates, I want to force my children classes to define how fast they spin. So I'm going to put this into the abstract class as well. So there we go. We have our basic setup of how we're going to approach this problem. Our instructions say next then, we need to start by implementing the optical disk, which is the interface. So let's go ahead and do that. I come back to IntelliJ, I right click, new, Java class, and then watch this very closely. I'm going to click interface and then type in optical disk. That will allow IntelliJ to create an interface for us instead of putting class here. Now I'm going to define those methods that we just talked about. First is spin disk. Remember, in interfaces, we don't put an accessor here because we know that it's going to be public because that's the only accessor type that can exist inside of an interface. So we say void and then spin disk with a semicolon at the very end. The next was store data. So we'll say void, then store data. We want to take in a parameter, the data to store. In this example, I'm going to just use strings as the data we're going to store in our disks for simplicity reasons. Then finally, we need the isFull method that returns a Boolean. If or if not, it's full. Great, we have our three methods that we said we were going to define. Let's go back. The instructions say next that we need to implement the abstract class, which we should call base disk, and then provide these methods in there. Let's go ahead and do this. I create the base disk class, and then I need to type in abstract here because it needs to be an abstract class. The first method that we said we were going to define was write data. So I say public void write data. Then I need to take in that data that we're going to write to the disk. Like we said before, we're going to use strings on this disk for simplicity. So I say write data, but we need to be able to store this data somewhere. We need to be able to write it to the disk. So what I'm going to do is come up here and create class variable. And I'm going to call it disk data. I created a class variable here, so now I want to naturally create a constructor so I can set that disk data to something useful. As of right now, I don't want to take in anything to set my disk to, because when we get a disk from the store, it's typically blank. So I'm going to set this class variable disk data to a blank string. So down here for write data, now I want to append any data that's being written to my disk to the disk data. So I append it by saying plus equals to a string, and I say data. So any data that comes in here will be appended to our class variable. Next up, read data, which is public and returns a string. And if the user is reading our data, we need to return the data to them. So we say return this.disk data. The next method we have to implement is getInfo, which is going to return a hash map full of that information about the disk. Well, if we have to return a hash map full of information, we need to have a hash map to return. So that means I'm going to create a class variable up here with a hash map. I'm going to call it diskinfo. That means down here in our constructor, we need to create an instance of a hash map. So we'll come back here in a little bit and populate this diskinfo with some information. But right now, we need to return the info to the user that's requesting it. So we say return this.diskinfo. Then finally, we need to create the insert method, which didn't return anything. And for this one, what I wanted to do is have a functionality that if it's inserted, then we're going to set a Boolean to say it is inserted. So to set that, we need to create another class variable. And when we first get the disk from the store, the disk is not inserted, so I'm going to set that to false in the constructor. But when we insert it down here, I want to set that Boolean to true. There we go. We've implemented these methods. Now, like we discussed, we have to implement those two properties, storage capacity in megabytes and spin speed in RPM, into our abstract class. So let's do that now. So we come up here, we'll say private int storage capacity in MB, as well as spin speed. There we go. And now we need to set this to something. But one thing you should ask yourself, can the storage capacity, the maximum storage capacity of a disk, ever change? Though CD and DVD are different, they have a set storage capacity, which can never change. If something can never change or stay constant, we should always set it to final. So I'm going to say final here. If a disk has a recommended spin speed, that can't change because the disk type will never change. So I'm also going to set this one to final as well. So now we're getting two errors here. This is because we created final variables, but we're never setting them. So we're going to set them in the constructor. So let's start with storage capacity in MB. We know that CDs and DVDs have different storage capacities. So we don't have anything to hard code this capacity to because it could be different. So if we want to customize the instance of our class, we pass information into the constructor. So we say int storage capacity. So now whoever's creating this disk can pass in whatever storage capacity that they want for this disk. And I'm going to do the same thing with spin speed, which we also need to take in the constructor. There we go. Now we're setting our final variable. So these can never change. This is going to stay constant. And everybody's happy up here. One last thing I'm going to do, like we said, we need to come back up here to disk info and supply some information to this hash map so we can return the information to whoever's requesting it. So let's go ahead and put this information in there. We know our key is a string, so I'm going to call this one storage capacity. And then I'm going to store our storage capacity. And then storage capacity is an integer, but we need to take in a string as the value. So what I do is I say string.value of and then storage capacity, which converts it into a string. Now I'm going to do the same with spin speed. So one more thing, what if I wanted to allow the user to create a title for this disk and put that into the information? Well, that means we need to overload the constructor. So what I'm going to do is that I'm going to just create another constructor down here that takes in a title. So we can title this disk. So what we can do is that we see that there's a bunch of duplicated code to set storage capacity and spin speed. Well, this constructor up here already deals with doing all of that. So what we can do is that we can say this and put in storage capacity and spin speed to pass it up to that constructor to do its work. And then down here, we'll say this.diskinfo.put title. You might notice I'm not going to create a class variable for title just because I'm just using string title as an example for this to overload the constructor here and use this. So if you do feel so inclined, feel free to put a class variable up here for title. All right, so we've created a basic disk. Let's continue. Next, I'll be to make sure the CD and DVD classes are created properly. So first things first, let's make sure that we extend base disk on CD and DVD. So we come back up to IntelliJ, we go to CD, and we extend base disk. We see that we're missing a few things, so we create our constructor, and now we see everything's okay. So what we had to do was just simply implement the constructor that base disk has, which takes in storage capacity and spin speed. Let's do this for DVD as well. Come up here, we implement that constructor once more, and this one I'm going to force to make a title. So we're going to take a title in for our DVD. So CD implemented just the typical constructor with storage capacity and spin speed, and DVD takes in the title as well as that spin speed and storage capacity as well. All right, so we are extending now base disk on DVD and CD. What's next? All right, so it looks like we also need to implement optical disk on CD and DVD. All right, so starting at CD, what I'm going to do is that I'm going to say implements and then optical disk. And we see that we're getting a few errors. So let's go ahead and implement these methods. I'm going to implement all of them. So we implemented spin disk, store data, and is full. So in spin disk, looking over instructions, what it wants us to do in this particular method is print out to the screen the rate at which it's spinning. So for CD, we say a CD spins at the rate of, and then we're going to print out the RPMs that we pass into the constructor. So it looks like this getter doesn't exist, get spin speed. We're not providing any getters or setters for our base disk class variables. So I'm going to go ahead and do that now because it looks like something we're going to truly need here. So first things first, I want to create a getter and setter for disk data. Well, we already have a getter for disk data, which is read data, and we also already have a setter, a very particular one called write data that appends our data to it. So I'm not going to create a getter and setter for disk data. Disk info. Disk info is set inside of the constructor here. So I don't want to change any of our disk info because once it's set in the constructor, it can't change. So now the getter for it is down here, get info. So I know I don't need a getter or a setter for disk info as well. So the next one up is inserted. We know our setter is down here, this insert method. So I'm just going to create a getter for it. So what I call a Boolean that's asking a question is inserted. So this is my getter for the isInserted class variable. Next, I want to create a getter for the storage capacity and the spin speed. But I'm not going to create a setter for these. Why? Because they're both final. They can't be reset anyway. So we can't create a setter for them. So there we go. We created 3 getters for isInserted, getting the storage capacity, and getting the spin speed. Let's hop back over to CD and see if anything changed. It looks like now we're able to access the spin speed from the base class. Awesome. Okay, so one thing now that I know is that we're in a CD. I don't want to take in any arbitrary spin speed because I know what a spin speed of the CD is going to be. So I'm actually not going to take that in the constructor. I know what it's going to be. A typical CD spins at about 500 RPM. So I'm going to pass that directly into the constructor. Same with storage capacity. I know what the storage capacity of a typical CD is, so I'm not going to take that in the constructor either. I'm going to pass it directly into our super, which I know a typical CD is around 700 megabytes after a few Google searches. So there we go. We are setting directly into our super the characteristics of a CD. We're no longer allowing our users to supply maybe false information about a CD. So let's go ahead and move on to now store data. So in our base disk, we have write data that appends all of our information to our disk data. Well, so it sounds like write data and store data do very similar things. And that's absolutely true. They do similar things. So instead of having 2 here, instead I want to maybe create my base disk as more of a private setter, something that only my child can access and only allows store data to be accessed outside of this class. We can do this by going to base disk and saying protected on write data. So now only my children can access write data when they want to. So let's go back up to that CD class. And what we're going to do is we're going to say this.write data and then pass in that data into this. Remember, we set write data to protected. So nobody outside of my family, those children and myself, can access write data. So this is a way we could maybe utilize protected to keep passing down this functionality into our classes. Finally, I need to implement the isFull method here. So I'm going to pretend that each character is equal to 1 megabyte in this example. So if it's full, that means the length of the characters of the data would be equal to or greater than my storage capacity. So what I would say is if this dot read data, because that's our getter for our data, dot length is greater than or equal to this dot storage capacity, then we're going to return true. It is full. Otherwise, return false. So this is how we can write our isFull method. All right, so now that we implemented optical disk on CD, let's go ahead and do the same thing on DVD. We see that we're getting those same errors. So we implement all of the methods. And now for spin disk, we're going to do similarly what we did for CD. And we're going to say system out.println. There we go. So we say a DVD spins at the rate of, and then we get the spin speed. Remember, spin speed is fairly set for disks. So I'm going to put this directly into our super. That's going to be passed down to our parent's constructor. I know that the spin speed of a DVD is around 1600. So I no longer need to take this into the constructor. So now my storage capacity of a DVD is usually around 4 gigabytes. So I'm not going to allow the user to say how much the storage capacity is in there. I'm going to say 4 gigabytes here, which 4 gigabytes in megabytes is 4,000 megabytes. But one thing you should note that I'm still keeping the title in here. I want to be able to pass the title in through the constructor because the user can title this disk anything they want. So I'm going to leave this like this. This will then print out a DVD will spin at the rate of 1600 RPM. So let's go ahead and do store data. Just like we did with CD, we're going to access that write data from our parent class and pass the data we're getting in from the parameter down to it. So we're going to write that data. And same with isFull. I'm going to copy this functionality that we have here over to DVD. So there we go. We have completed writing our DVD class. All right, so now it's time to take what we've done and actually test it in main. So we need to make sure we create a DVD and a CD, and we're going to spin the disk and see what happens. So we come up to main and we create first a CD. Next, we're going to create a DVD. We see that DVD actually needs to take in a title. That's because if we remember, our constructor needs a title to create a DVD, unlike CD, where we didn't include a title in that constructor. So we created my CD and my DVD, provided the DVD a title, and now we need to spin the disk. So we say mycd.spinDisk, and then we say mydvd.spinDisk. Now we see we can access spin disk on both CD and DVD. Even though they're the same method spawning from our single parent, we should get two different outputs back. So let's go ahead and run this and try it. And we see that our CD spins at a rate of 500 RPM and the DVD spins at a rate of 1600 RPM. So we see that we're using the concept of polymorphism to customize these methods to do what we want. So I see that these two spin disk methods work, so I see that my application is working properly. I can continue to test out a little bit more here by saying mycd.writeData. What I can do is then I can make sure that the data is actually being written. So let's go ahead and try this out now. Perfect, so more data to write is coming out properly. So we can continue now here in main to test out what we've done with inheritance, as well as implementing interfaces and extending abstract classes. I do invite you to go in here and get your hands dirty to see exactly how everything is interacting. It really does go a long way. So once you do that, we have finished this studio. We got into the nitty-gritty of inheritance, working with those abstract classes, and implementing interfaces, all to create one single application. And it really does save us a lot of lines of code to do this. So I hope you got a lot out of it. Stick around to do the bonus missions. All right, let's move on to the bonus missions. The first thing we need to do is add more disks. It says we need to create an LP, a vinyl disk, and a floppy disk class. So let's go ahead and do that real quick. So we come up here, right-click, new, Java class, I'm going to call it LP. Then we do the same thing for floppy disk. Awesome, we have these classes created. What do we need to do with them? So now we need to answer the question, can we use the same interface? Can LP and can floppy disk implement the optical disk interface? So let's double check these behaviors and see if we can actually do it. Going to the optical disk interface, we see that it has is full, stores data, and spins disk. Well, we know that a floppy disk does spin within its cartridge, it does store data, and it can be full. So floppy disk is check. So let's go ahead and implement optical disk. So let's go back. How about for vinyl disks? Well, the vinyl disk does spin, it stores data, and it can be full. So yes, vinyl disks or LP can also implement optical disk. Great, there we go. But how about with the abstract class? Let's double check these behaviors too and see if we can have it extend our base disk class. We go to base disk, and let's go ahead and just look at the class variables. So we see disk data, disk info. Those two do go with vinyl and floppy disk. They both hold data, and they both have information about them. They also have a storage capacity and an RPM, but floppy disks can be inserted, but vinyl records can't really be inserted. So is inserted might not be the best property for a vinyl disk or an LP. That being said, going down to the behaviors, so we can write data to the disk, we can read data from the disk, we can't necessarily insert our vinyl record or LP into anything. That goes onto a spin table instead. So because insert doesn't necessarily work for a vinyl disk, what I'm going to do is I want to move this method into something a little bit more specific that goes with floppy disks, DVDs, and CDs, but not LPs, not vinyl disks. So what I'm going to do is that I right-click, new, Java. I'm going to call this computer disks. And what I'm going to do is to have this as an abstract class. And this is also going to extend the base disk class. So now I have an abstract classes just for computer disks that extend all the functionality of base disk in it. So I go to base disk and I want to get rid of this insert. So I'm going to take out that. I'm going to place it into my computer disk. There we go. Now insert is a part of the computer disk abstract class, which is more specific than base disk. Moreover, we need to get the isInserted class variable out of base disk. So let's go ahead and get that. And we're going to pull our class variable at the top. As always, we need to get our getters and setters as well. So here is our getter. Our setter is that insert method. I'm going to place that down here. Great. And one last thing we need to get this is inserted out of this constructor and place it into our computer disk constructor. So we can set this. There we go, we created this computer disk class now. But no one is actually extending computer disk, so we need someone to extend computer disk. Why not all the disks that go inside of a computer? Starting with DVD. Instead of extending base disk, it's now going to extend computer disk, which extends base disk with the addition of that insert method. Same with CD. And now we're going to extend computer disk into floppy disk, and we're going to create these constructors. Awesome. As always, we can edit this super here to take in a hard-coded storage capacity and a spin speed. So now we go over to LP, and we can say this one doesn't extend computer disk, but extends a base disk. There we go. So now if we want to try to access anything from computer disk, such as insert, we don't get that option. We can only extend things from the base disk class, such as read data, write data. So there we go. All of our classes are happy with all of the implementations of methods that they should have. So this is how we can use inheritance, interfaces, abstract classes, all to our benefit to give our classes exactly the behaviors and properties that they need. Let's keep going. What if we created a Frisbee class? Could we use our interface or the abstract class? Well, let's go ahead and talk about it. Created a new class called Frisbee. And so now we need to check on the behaviors. Let's check about optical disk. Well, a Frisbee can spin, but a Frisbee cannot store data and nor can it be full. A Frisbee is just a toy that spins. That's it. 2 of the 3 behaviors wouldn't fit. So we know from this, the interface here, optical disk, is not for Frisbee. Going to our abstract class for base disk, we also know that this probably won't be the best for Frisbee as well, because Frisbees don't really hold data, they don't have information, and they don't have a storage capacity or spin speed in here. So we wouldn't want to necessarily extend base disk on Frisbee as well. So in the end, we would have to create a completely new abstract class with a Frisbee's own behaviors in it, if we wanted to extend an abstract class from Frisbee. In addition, we would want to take the behavior spin disk out of this interface and maybe make a new interface that Frisbee can extend. So in the end, this was just a fun exercise to kind of explore what we could reuse and how we could reuse it if we had such a different disk like Frisbee introduced to us in this application. I just wanted to go through this quickly. I'm not going to implement any of this. This is kind of just a small explanation. That being said, we are all done with this studio. From start to end, we have finished the bonus missions. Thank you for working through the studio with me, and thank you for watching.